Ну, сейчас у нас доклад на полчаса, очередная сессия.
We have next session for 30 minutes. Ivan Muratov will tell us about Postgres, PostGIS, and ScaleDB. It is combination of new developments with legacy. The buzzwords which were in the initial speech of Oleg, can you all hear me? If you have any technical issues, please interrupt me. We will fix it. So before I start, you can scan QR code on the second monitor. I promise that I won't give you too much text. We can begin.
Okay.
Okay, once again, I'm Ivan Muratov. I work in the first monitoring company in Krasnodar. We are dealing with satellite monitoring of transport. We love Postgres. I'm the member of the board of the biggest Dev Days Krasnodar and the founder of BG Meetup in our city. So if you are from our region, you can write me if you want to have a speech in our conferences. I give you some links to our community. I was a little bit shy when I sent my application and then sent more than 100 slides. I promise not to go over all of them. You can ask all questions afterwards or ask me in the lobbies. I will glad to discuss any issues with you. Our company is engaged in GPS and GLONASS navigation, so the telemetry fits perfectly in the concept of the data management, such as temperature, destination, and other things. And taking into account our industry, we need to check the speed, routes, and the coverage of agricultural technique and many other things. Also, telemetry fits very good not only in some scope of tasks, it can be also used in defense and transport monitoring and any other types of monitoring, organization of agriculture. Of course, we shouldn't forget about such things as Internet of Things and smart homes. This IT industry still developing, and the temperature in your fridge, light in your rooms is also telemetry. And here you can see the dynamics of popularity, different approach to data storages. As you may see, the last 2 years, TM series is leading and GraphBase are on the second place. So we have an extension for DMDB, and for ScaleBase you can make a very good startup. For MT series, we can see lively dynamic in TimescaleDB. It's very good that the correlational database extension can compete against solutions which were designed initially for TM series data. So about our stack, I think you know about ALK stack. Let's take the same abbreviation PPT. It's just design tables. This stack is not a silver bullet, but for me and for my company at least, it's probe 925. The question is why serious data should be written to a relation database. I think we have the answer because we can do this. A few days ago we asked why we need to write JSON to a relation database. The question for us was obvious. It was risk management. We're engineers, we solve business problems, so we have to minimize our risks. and the expertise with Postgres and positive experience of working with it, overweighted unknown technologies. And at the very start we took InfluxDB, but we stopped at the right time. In these lists you can find dozens of different TM series databases designed for time rows concept. The first member of this stack, Postgres, shouldn't be introduced. This is the purpose of our discussion today. It is in line with the SQL standard. It has an open code. It has a wonderful community and wonderful documentation. Postgres is not only the object relational database, it's also a platform to design specialized solutions. Using own aggregates, using own indexes and data, you can make your own extensions as PostGIS and TimescaleDB. In Postgres, without extension out of the box, there are a lot of good things. For instance, geometrical types of data and functions. Of course, they work only in a Descartes system. They are not suitable for geospatial calculations because the ground is not flat. The Earth is not flat. Of course, for our business we need spherical coordinates, and Postgres has a certain set for mathematical functions, correlation of percentile packages, buckets. You will need this for statistics and analytics. Separately, I need to mention non-structured data, JSON and JSON-P. Yesterday we had a wonderful tutorial on this topic. This would solve the problem of properties which are needed only for a small number of objects from the whole set. When you don't know what will be the framework and what data set it could contain, the essence of your domain model, you will either add columns which will be empty in many cases, or you will attach tables which will be joined based on the initial key and supplement properties which only a small sampling will need. Next component, PostGIS. PostgreSQL was a topic for me in the university years. Everyone who works with Postgres heard about this extension. This extension allows to make geospatial calculation. It includes several dozens of types of data and some types of functions. What is PostGIS? First is OpenGIS consortium specification, 2 backend geos and SFSQL, which can be dynamically switched in runtime. You don't have to rebuild extensions to use any of the backends. Of course, work with raster and vectors using GDAL library, Tiger for geocoding, and OpenStreetMap is using Tiger. PostGIS extended specification of OpenGIS by supporting 2D and 3D coordinates. So if you had a dream to make metro map in the hyperspace, PostGIS can do this. You can work with data in the well-known text and well-known binary formats. The main difference is that well-known text is human readable and well-known binary in HIC format, supporting more than 3,000 geolinks. You know all G84, where coordinates are by latitude and longitude, and in decimal form, but there are thousands. Every state in the United States has 2 systems, one metrical, the second one an English system. We had 4 standards, that's a joke. We have 5 standards which combine them. So we have CRS for Mars. So if you wanted to make a system for time schedule for Mars, PostGIS allows you to do this. Of course, it's dimensionally in standard 9 model. This is a model of geometrical objects of geospatial type and their connection between us, partial interception at the border, and so on and so forth. It's a specialized indexes based on R trees, geohashing support, and GeoJSON support. You can take your GeoJSONs and use them as a leaflet on the front end. PostGIS provides, according to OpenGIS specification, the whole hierarchy of objects with their own data types. They are discussed as superset simple futures. Also, PostGIS provides thousands of functions for geo calculations such as route calculation, scope of and entering zone, residence in one zone. Everything can be built based on this extension. And TimescaleDB, the third, last but not the least, extension allows to store time series data in the relation database. TimescaleDB works with MCS data, which peculiarity is the initial key is time, although any value can be suitable for that. And time series data peculiarity is the fact that you write it to the database, store it there, and delete data if necessary, which are outdated. But the update of query is not done because it's of no point for you to change CPU load of one week ago if you don't want to cheat someone. Time series data allow to store efficiently and to split efficiently your partitions based on timestamps. TimescaleDB provides such abstraction as hypertable. Hypertable in time series terms is any simple table which you would use a special function, give the name and time series dimension, which is normally time. If necessary, you can indicate additional dimensions based on which you will provide partitioning for your table. TimescaleDB during hypertable creation would automatically make so-called chunks for you. Chunk is a partition, but at the same time, time series launches a background worker which is responsible for sectioning. You shouldn't create triggers, you shouldn't find out logic, you shouldn't rebuild indexes for daughter tables. Everything is done by Timescale for you. Timescale claims that if it can work with 10,000 chunks on one Postgres instance. TimescaleDB allows under relational algebra conditions can work also with geospatial data. We should note that Timescale doesn't place any limitations on SQL or Postgres system. Oleg told in his presentation that previously the pipeline DB was a separate fork. TimescaleDB was initially an extension, so it has no influence on the way you worked with Postgres previously. By the way, TimescaleDB, since some versions, provides a better version of its cloud solutions and enterprise support of the extension. Why DB? TimescaleDB writes that they have a time series database with open source, although it's just an extension. Probably ZomboDB, PipelineDB are also similar here. They use a similar technology. Just the DP prefix sounds more business-like for your startups. We should say a few words about PipelineDB. It's about time series data, but it's more oriented on real-time event streaming and not on data storage organization of a big data array. Both these extensions claimed their first release a few months ago and readiness for industrial operation. But these solutions were not from yesterday. PipelineDB develops since 2013. I have two sample examples here to show you that working with this stack, with this extension, you stay within the SQL framework you're used to. You have just to study the set of functions and data the extension work with. The left query allows to get you this average minimum and maximum speed with windows of 1 hour. The second query is complicated. It allows to bring up day by day the number of vehicles running out of Krasnodar and the total tonnage for this period. Separately from Grafana 530, TimescaleDB command designed native support of its extension for Grafana using Postgres as a data source. Of course, it allows to make very interesting and complicated business intelligence in the database It may be interesting for your business department. When you use Grafana with Postgres and Timescale, you have all functions and in store for TM series data, first, last, bucket, and others, and also the opportunity to group some windows to execute so-called gap filling and interpolate missed pieces. In January, we have an release of next version with Zabbix, and starting from Zabbix 4.0, you can use functions from Timescale using Zabbix, and you can build up interesting graphs. What is in the result? As a result, based on the object relation DBMS, an opportunity to work with unstructured data with geo objects, and at the same time we do not move out of the ecosystem Postgres system, which is the most powerful one. We stay within scalability solutions you got used to. We can use other extensions you liked. We can use same systems of backup, and of course it's an open code and free of charge use. I believe this is just an excellent stack to start any monitoring systems. I hope any telemetry will fit perfectly into this scheme. And in the last slide, I have links for Postgres and post links for Timescale, interesting my information, and the link to demo. Since we have only 20 minutes, we couldn't see any more. A reference to the ready Docker image, an interesting project from my colleague and friend from the organization committee of our conference, GeoPuzzle based on Postgres and Python. And basically this is a puzzle of countries on our planet. That's really cool. Thank you very much to the organizers for the invitation. I hope you will have a great time here in the conference. I'm ready to take your questions.
Отлично, отлично, потому что очень много хотелось рассказать. Наверное, будет второй доклад. Следите, хочу сделать развернутую.
The graph bases, what's so bad about them? One more time. The graph bases compared to the Postgres. This is not the correct question. The graph basis is the reason how to organize the data, and Postgres is realization of this. You probably need to paraphrase your question. I wouldn't write the bank transactions into the graph base because it doesn't make any sense. I do not know how to create the base and the types of the bases. But the trend, as we said with DB agents, so the graph basis is popular. It takes the second place in popularity, so you can set up the extension. We're talking about the GIS. It has to do with GIS maybe, because you've mentioned the graph base, and this is why we paid attention to that. I need them because they have the time series, they take a second place, and there is a big gap between this popularity. Thank you for such a good presentation. So you've been using it, yes, for 1.5 years. Can you say a few words about your experience of using that? Because it sounds great. The same like it is with JSON. And a small remark, your opinion on why we use JSON, and traditionally we like it and we can. This is the opinion that I have. I'm not limiting myself to mono or influx. If everything's working fine, then yes, for 1.5 years it's in production as an amount in a telemetric company. We have 4 years, 6,000 objects in Krasnodar region, and it's 8 terabytes of weight. And the specifics of our area is based on the business. We create the reports, monthly reports, and we have it like annual reports, so we cannot keep them for the last 2 months. So we need to create the reports, annual reports, so we can divide the chunks on 50, 10 gigabytes, and sometimes 10,000 chunks. This is great. So thank you for your question. You were speaking about the finding a filling, about using the Grafana and DB. Can you speak a few words about that? I will explain myself. The versions 1 and 2 been realized with that gap filling, and it has two solutions. The problem is that when you have time series, then some of the characteristics of time characteristics for 1 hour, let's say your equipment is not running and you have that gap because nothing is being sent. So this gap could be completely empty, and this is not good for the statistics when you are uploading it. So this thing will help you to do the lining interpolation, to have the connections and to have this meaning in different spots. Or the last meaning, the line, and up to that figure which we knew. One more thing. Those are the possibilities of the chunks, creating the chunks. Apart from that, you can write your own base. No, it does not allow me to write the base. It's this. What, apart from partitioning, does the scaling? Maybe it has some better performance. Can you give us some figures that you received during using that? Talking about with Oleg Brodunov, Timescale was developing the pace, which performs the partitioning. And Postgres, you need to specify based on what you do the partitioning. When you have a new month coming in, you need to add new trigger in order to write this new partition. And Timescale with its worker is Timescale integrates into the planner and the Postgres require fulfillment, and it allows less functions because you build up the windows, the buckets, so to say, when you put the data together, and you do not need to bring every dot from the telemetry. You take the data from the last minute, and based on the database, it's faster than to bring millions of messages from the backup and do the average by minute. And there are functions like first and last. You take the first one or the last one from the window. Less functions. You need to review the documentation based on Postgres. Your head does not blow up, so to say, when you look at it. And partition, for instance, if you don't need time series data, then being it's realized into classifying the partitions, I really like the way it is. Even without time series data, I think you will be using it. As I've said, we've been using it for 1.5 years. Nothing failed. Everything is compatible and working is running just fine. Have you made measures of the performance of PostgreSQL, or do we have hundreds, thousands of geo objects, or maybe some of the performance was slow and then you did some things in order to increase it, to make it run faster? Postgres deserves separate presentations, and I think we have 2 or 3 presentations during this conference. I think we'll have one more presentation about Postgres. If you didn't have a chance to listen it, then you can watch the videos for this presentation, talking about the performance and the production. Speaking about the big objects, you can do the preliminary optimization and make simple geometry. We didn't have the task to take billions of fields for the year and for billions of objects. You need to create some pool of tasks and do it parallel. I don't think you can do it at one time. I just don't think any base will cope with it. So thank you for your presentation. My question is that during using this, what was the volume of your database? 8 terabytes. As I've said, that's total amount of data. So these are the data that are accessible online and for the annual reports, or else if it's in a system which we integrated the stack, then online it's accessible 1.5 terabyte for annual reports. What version? 10.6. That's vanilla, standard. Yes, we didn't use any other forks. Thank you. One more question. The last question, please. Here I am. Please tell us more about creating reports for a long period of time. We use like some raw materials, we have some aggregates that compile this type of information. Well, the aggregation of some sort of cache at the neighboring table space, we don't do that. But the partitions are organized that way that they are divided by themselves by time or by the sizes. So when we take out some data about the object for the year, the average, I can calculate it, navigation objects or equipment brings us 5 to 6 dots per minute. So one object generates hundreds of gigabytes per year. So if the big report is built up, so we will not build it up for many objects. It will be the report will be given for one object, and if we take it out by pieces, like month by month, and then we merge all this information. So we review it, we review a huge amount of data, but then we get 50 pages in PDF in the end. So we divide it in by business codes. So when the client is asking for the report, we tell him that he needs to wait for a little while. Okay, about the details of making the reports, I think you can talk about it a bit later personally. Yes, front end tells him to wait, but it doesn't take much time to create such reports.